The following presentation demonstrates the use of the sand cone method to determine the moisture content of soil. We're going to need the following equipment: a scale, a Proctor mold, plastic bottle, sand cone, base plate, trowel, and the evaporating dish. The first calculation we need to make is to determine the dry weight of the sand being used. For this, we need to first find the weight of the empty Proctor mold. We get 3.788 kilograms. We'll refer to this weight as W1. Now we must fill the Proctor mold level to the top with dry sand. Now we weigh the full Proctor mold. We get 5.219 kilograms. We'll refer to this figure as W2. We need to know the volume of the Proctor mold. In other words, how much sand can it hold? This volume is 0.00095 cubic meters, or V1. When we take W2, the combined weight, and subtract W1, the mold's weight, we then divide that value by V1, the volume. We get approximately 1,506.3 kilograms per cubic meter. That's the dry unit weight of the sand. The next calculation to make is to determine the weight of sand needed to fill the sand cone. The first thing to do is weigh the entire assembly of the sand cone and the bottle filled with dry sand. We get 7.076 kilograms. We'll refer to this weight as W3. Next, we make sure the cone's valve is shut. We invert the cone. Then, the valve is open so that a full cone of sand is released. The valve is to be closed again. Now we weigh the full assembly. We get 5.378 kilograms. We'll refer to this weight as W4. We can now determine the weight of sand required to fill the sand cone by subtracting W4 from W3. We get 1.698 kilograms, and we'll call that figure WC. Out in the field, we must first secure the base plate to a level area of ground. We now dig a hole about 10 to 15 centimeters deep. As you are digging the hole, put the retrieved soil into the plastic bag in order that the soil does not lose moisture. With the valve closed, turn the bottle and cone assembly upside down and place the cone in the center hole of the base plate and open the valve so that sand flows. After flow of sand stops, close the valve and pick the assembly up. The sand in the cone will be poured into the base plate. Back in the lab, we now weigh the complete assembly again. The weight is 3.529 kilograms. This is what we will call W5. If we take W3, the weight of a full sand cone assembly, and subtract W5 and WC, and divide it by the dry unit weight of the sand, we get the volume of the whole, which is approximately 0.00122 cubic meters. We'll call this figure V2. Our final calculations will require another series of weighing. We'll start with the evaporating dish. It weighs 0.462 kilograms. We'll call this W6. We then put all of the collected soil into the dish and weigh this. We get 2.723 kilograms. This is W7. Next, we put the evaporating dish and wet soil in the oven. After 24 hours, weigh it again. We get 2.621 kilograms. This is W8. Now we have all the data we need. We can calculate the moist unit weight of the soil by subtracting the dry weight, W8, from the wet weight, W7, and dividing that number by the volume of the whole, V2. We get 83.6 kilograms per cubic meter. To calculate the water content, subtract W8 from W7 again. This time divide that by W8 minus W6. We get 4.72%.